Hi, everyone. Thank you all for being here today. Also, thanks to Ceci, thanks to Gloria, and thanks to the UpGlo team for the opportunity. And just a note before we start, as always, the slides and the transcript of this talk will be available for you later, okay? So next slide, please. Oh, I think awesome. Thank you, Ceci. So I assume that most of you know me already, but for the ones that don't know me yet, hi, I'm Alex. I graduated in mathematics. I got my master's and my PhD degrees in Brazil. And I worked as a researcher in Brazil and in Germany before coming to the US. And my native language is Portuguese. So next slide, Ceci, please. All right, as you know already, this is our theme for discussion today, Python. So let's discuss a little bit today about why to use Python, where is it used in the wild, some packages to use for data science, some tools to make your programming easier, and how to start writing code and creating your portfolio, okay? Next slide, please. So first of all, maybe you're asking yourself, why should I use Python? Why is it significant, right? Let's talk about Python's history first, so we understand it a little bit. So for some of us, like myself included, it is kind of difficult to understand why someone would write a programming language, right? So what kinds of problems does someone have that a language already available wouldn't solve? So next slide, please. So this is Guido van Rossum, the creator of Python. So at the time, he was working as a programmer on the CWI in the Netherlands. And he had some ideas from when he was working on a language called ABC, which was designed as a language for non-technical writers. And then he started writing the first version of Python as a hobby project in December of 1989. Next slide, please. And then here you can see a small comparison between ABC at the time and Python in a function to get all words in a document, right? So check the structure like for something, in something, if something, not in something. They kind of look alike, right? And Python was designed like ABC in the sense that it's easier to read than other languages, and it's kind of close to English. Also, Python's code is often shorter than code in other languages, so you can write more code in less time, and you will feel that you do a lot with a few lines of code when using Python. So next slide, please. So Python is a general purpose programming language. We say that general purpose means that it can be applied across several domains, and that is one of its major strengths. So you can use the same language to create a website, to program a robot, and of course to do data science, right? And Python has a very extensive standard library with lots of functions, so you don't need to write the basics from scratch. Also, there's the Python package index where you can find, install, and even publish your own packages. So packages are extensions for your code written by other people and are being used and tested for the whole community. So right now, PyPI has more than 300,000 projects with code that you can download and use for lots of applications. Most of this code is open source, so you can learn and read and learn from it too. Next slide, please. So since Python is a general purpose language, easy to use and write, to understand, people started to write their own packages and extensions, right? And developers started to use Python everywhere. So web development, education, scientific research, so on. But I will show you two of the coolest applications I've seen recently using Python. The first one is this one, when Python and its packages were used to create the first image of a black hole. So here, a team of researchers from the Event Horizon Telescope collaboration used packages like NumPy, Pandas, and AstroPy, among others, to generate this image from the center of the galaxy M87. So you can see it here on the left, right? So this is the first image of a black hole, and it was made using Python. Next slide, please. And the other one is that Python, its packages, and other open source projects were used by NASA to fly the Ingenuity helicopter on Mars. So how cool is that, right? You have a small helicopter on Mars, which is running Python and other packages. So next slide, please. And to finish this part, I cannot talk about Python without talking about its community. So Python's community tends to be very open, very respectful, diverse, and fun. And there are groups like the PyLadies, which provide a friendly support network for women interested in Python. We have PyLady groups around the world, and there's also PyData, which is very interesting for us as data scientists to be. And PyData provides a place for users and developers of data analysis tools to share ideas and learn from each other. So next slide, please. So as we said before, we have several packages for Python, and some of them provide good tools to work with data science, right? So let's see some of the most used ones. Next slide, please. I see. So the basic packages we are interested in are NumPy, SciPy, Matplotlib, Pandas, scikit-learn, and stats models. So if you saw the first webinar of this series, I'm gonna repeat myself a little bit here, but let's remember what these packages are. So first, NumPy. NumPy is the basic packages for numerical operations in Python. So it provides you with an object called an array to store your numerical data, and everything starts from there. So it has some statistical functions and linear algebra inside as well. Then you have SciPy, and SciPy is a huge package that provides many numerical algorithms. So for example, it has functions for image processing, linear algebra, statistics, graphs, and so on. Matplotlib, in its term, it's a package to create visualizations in Python, animated figures, three-dimensional plots, you name it. So you can do all of that with Matplotlib. And together, NumPy, SciPy, and Matplotlib are known as the core packages for scientific computing in Python. So now let's go for the more specific packages. So you have Pandas, and you use it a lot for data analysis and manipulation, because using Pandas, you can read spreadsheet files, you can create tabular objects, clean your data, analyze it, and more. When you do data science with Python, you will probably spend a lot of time using Pandas. So now let's see stats models. So it's graphed wrongly here, but it's stats models, don't worry. It provides functions for many different statistical models, tests, data exploration, and so on. So if you search for some very different statistical function and you don't find it in the packages like NumPy, SciPy, or Pandas, there's a pretty good chance that model has it. And then finally, there's scikit-learn, the main package for machine learning in Python. It is very well known and used, and it has most of the tools you would use for data science. So algorithms like for classification, regression, clustering, and so on. So next slide, please. So, all right. Now that we know the tools we are going to use when doing data science, let's discuss where are we going to work. Next slide, please. So this slide is very cheesy, right? So this way you won't forget it for a while. Just some advice before we proceed. Maybe the tools we're presenting today are not right for you or for the work you would like to pursue. So please do not attach yourself too much to any specific tool, right? So throughout your career, you will see a lot of tool cheerleaders in IT, you know? So I use it, I use X and it's amazing, and you use Y, so you're not amazing, you know? So something that will take you far, if I may say, be competent in some tools and know where they can be used. You will learn with experience where to use each tool, right? So please don't go into that wave of Python is the best, you should be using it instead of that, or Python is terrible, it doesn't fit, it doesn't suit me for anything, you know? So every tool has its place and time. Next slide, please. So that said, let's talk about Anaconda. So Anaconda is an open source distribution for Python that has all the packages you need to start doing data science and data analysis. So NumPy, SciPy, Pandas, everything is there already. So we left some references on how to install it for your system on the slides at the end, okay? So next slide, please. Then after installing Anaconda, you have a lot of packages in your system. Now, how to interact with these packages? How to write Python code to using these packages? I'd like to recommend Visual Studio Code as an environment for programming. So it's a robust, fast code editor with lots of extensions for you to add more capabilities for it. So the Python extension, for example, works well with Anaconda on any operating system, and it auto-completes code, and it can show documentation as you type your Python code in it. And VS Code is great because it doesn't work only with Python. You can use it for R, for C++, for Java, you name it. And as we did with Anaconda, we left some references on how to install it for your system on the slides at the end. And there are some tutorials on how to start using it with Python as well. Next slide, please. Now, let's talk about Jupyter Notebooks. You will hear a lot of them while learning data science, and mostly while you're learning Python. So Jupyter Notebooks are part of the project Jupyter, which develops software and services for interactive computing, right? And they can contain code and text into different cells. So they're great to do exploratory data analysis, to test different visualizations, and to write tutorials as well. In fact, most of the tutorials you'll find nowadays were written in Jupyter Notebooks. So Jupyter Notebooks support over 40 programming languages, including Python and R. And there is an extension for Jupyter on Visual Studio Code. It is installed together with the Python extension for Visual Studio Code. So you can open your notebooks within VS Code, within the editor, or you can use them from an internet browser, but it doesn't access the internet, don't worry. So next slide, please. So we saw a little bit about Python, the packages you will use for data science, and some tools to start working with. Now on to the learning stuff. How to use these tools, how to learn the techniques and create our portfolio. So next slide, please. One good place for you to start is checking Kaggle basic competitions. So while Kaggle has a lot of competitions where you can earn money, there are some that provide you with knowledge on some kind of data. One example is the Titanic one, where you will predict which passengers survived the Titanic shipwreck. So this is a very well-studied challenge already, and almost everyone at Kaggle has a solution for that. But most of these solutions are open, so you can learn from others too, while creating your own solution, right? So next slide, please. You can also check tutorials on the packages you want to learn. And the secret here is not blindly following tutorials, but interacting with it, you know? So most of these tutorials have download buttons, so you can download the code and run it on your machine. So I'd recommend you to type line by line of the code instead. Maybe try to change a value on expansion or to see what happens, or try to change a color on the plot. Maybe use a different data set to do the same thing, something like that. Next slide, please. So besides going through some tutorials and challenges, you can also check the PyData conferences. So they're a great place to learn more and also to meet people interested in data science. They're not happening that frequently right now because of pandemic, but you can see their YouTube channel. Most of the talks that happen there are on their channel for you to watch whenever you can. You can check some PyData talks and other gatherings on data science using Meetup. So go to their page, type data science and your place, and you're good to go. Most of them happen online nowadays, so you can watch them from home and from like everywhere. You can see conferences from San Francisco when you're in New York and so on. These meetings can give you a lot of different ideas and information, even on work opportunities. So next slide, please. When you're more seasoned on how to work with data, you can go to some open repositories and work on their data. So you can use what you have learned so far with the tutorials, with the Kaggle challenges, and you can explore different approaches for a data set on your seed, on your CD, for example. So you can check if you can, first, please check if you can use that data freely, right? Because most of the open data sites will let you know if there are any limitations on the use of that data. So using these kinds of data, you can answer questions about your community, for instance, and you can try different visualizations as well. So you will learn more in the process. Next slide, please. And while you are doing these things, it's interesting to put all your work on GitHub, okay? So you will train your GitHub skill and have your portfolio ready when you want to apply for a position. So you can add the solutions for your Kaggle competitions, you can add your versions of the tutorials you have followed, your ideas, and so on. So if you're in doubt on how to use GitHub, please check our last webinar. So we have tips on how to open your account and a step-by-step example on how to add data to a repository, okay? So don't forget to give credit to the code, tutorials, tools, and data you used in when you use them. So cite them on your portfolio, remembering to include acknowledgements for other people's code, for example. Next slide, please. So, all right, everyone, we are reaching the end of this webinar, but before we finish, next slide. Sorry, I'll get there. So let me talk about my path with Python a little bit and how Python actually fits into it. So the first language I learned a little bit was Clipper. The staff at my school, at my high school at that time, had this huge Xerox box, and I made a copy for myself, and it was downhill from there. I had this friend who used to bring me books from the university. I learned a little bit about C, but not enough to do anything serious. So, well, I didn't know what was serious at that time. So I used to write small programs to ask for name, converting Celsius to Fahrenheit, for instance, and so on. Then I went to the university and I had Pascal classes in the first year. So a professor taught me a little bit of R once in a short course, but it was just 2 hours. And it was nice to have some ideas about R though, right? And more towards the end, I learned MATLAB and I started to work with image processing. So I worked with MATLAB for about 10 years until the first year of my doctorate. When I started writing papers, I figured out that the statistical part of MATLAB could be a tad better. And then I started using MATLAB only for image processing and R for statistical analysis and plots. And at that point, around 2013, I went to a conference in Argentina to present my study so far. And some people liked it and came to talk to me later. And I described it, what I was doing in more detail. And I said something like, hey, all your code is available and you can use it whenever you want. Their answer was, we can use MATLAB. You know, we cannot use MATLAB because we don't have the money to maintain it. And then I thought there were a lot of people around that don't have money for it, right? Well, I used it because the university paid for it. And I know that even the professors used pirated copies of it, you know? So I thought that to do open source correctly, I should go for an open source language. And then I started seeing things in Python, scikit-image, NumPy, SciPy, and I could do all my work at the same way, and I could contribute back to the packages, learning in the process. So I thought, this is the way I will do it from now on. So I've been using only Python for my work since. And there are some R as well, but mostly Python, and R is open source and freely available too, and that's also great, right? And I remember I had a discussion with one of the professors I wanted to work with around that time, and I was discussing how I wanted to learn Python and so on, and she scoffed at me, you know? Then she said that the good programmers, the real programmers, the ones at the top of their game, they use C++. And that bothered me for a while, but I didn't pay attention in the end. And I'm glad to know today that she was wrong, because good programmers are everywhere, you know, using the tools they want whenever they see the necessity of using them. And you will find lots of people like that when you're starting something new, right? So people that are telling you, good people do that, real programmers do that, this is better than that, and or that is a waste of time, you know, without explaining their point, right? People don't trust, please don't trust these people that much, okay? If you're interested in their point, ask why. It's like, why is this the way to go? Why not the way I'm seeing here or I'm learning? And check their answer, see if it makes sense, and try it yourself, you know, because knowledge is never lost. In my case, Python and its community gave me a lot. The job I have today, for example, and I feel grateful I took the time to learn a little bit about it. So here at the end, I've listed some resources we used for the talk, and you can check them to learn more about Python. There are some interviews, and we also try to add some books and courses that you can access with no cost. And next slide, please. So next slide, please. So there's an account of VS Code. Next slide, please. And open data. And next slide, please. Yeah. So I think that together, since we have 30-40 minutes only, I wanted, as we did with GitHub, to give you an icebreaker, right? So you see, when you go to your courses, you can see what's what and what would you would like to learn, and what tools can you use when you're when you're starting learning Python, you know? So we don't rush in 40 minutes. Like on GitHub, you can explain what a repository is on 40 minutes, and then you can figure out by yourselves in your courses. But Python is a very vast language, and you have several packages. So I think these that we're having today will be a good start for you to actually checking data science out. Okay, and I wanted this one to be shorter, so we have more time on for your questions. So please ask anything about Python data science and I'll try to answer your questions to the best of my knowledge. And I said in the beginning, the slides and the transcript of this talk will be available. And thank you again for being here.